Yes. All right, wonderful. This is what I meant with the weirds. All right, thank you. Hey, my name is Jan Jongboom. We're going to be doing a bit of talking head here for about an hour and a half. Tell you everything about LoRa, everything about LoRaWAN, a little bit about MBED, a little bit of Things Network. After that, we're going to do hands-on. So we have, as said, 25 kids with us. We have networks actually operated here. There's a gateway already there in the outlets, a really small one, the new one from Things Network. Johan will talk a bit about it. So my name is Jan Jongboom. My main job is that I'm Principal Developer Evangelist at ARM. So I'm overlooking what ARM is doing in Internet of Things on a software level. So I run a small team. We have people in Asia, US, and me in Europe, and we travel around. We spread the word of the Internet of Things and everything you can build with that. And I'm joined here on stage with Johan, and I know Johan mostly from the LoRa Alliance, where we're both sitting in the technical committee. So the LoRa Alliance overlooks the LoRaWAN standard, and together we try to progress that standard a little bit further. So, and I'll hand it over to Johan, who will introduce himself and talk about LoRa and LoRaWAN.
Awesome. Okay. So, good morning, everyone. Happy to be here. My name is Johan. Like Jacco said and Jan said, I'm co-founder of the Things Network. We are a relatively small company, the Things Industries, building the Things Network. That's a community and a network and an open source initiative. And we are about 18 people based in Amsterdam, and I'm mostly involved in the technical strategy, architecture, operations. So let's get started. Internet of Things. I think it's always good to put Internet of Things a little bit into perspective. So as you know, there are a lot of wireless technologies that you can use and that you can mix to drive IoT solutions. And many of them are actually built for human interaction. So Wi-Fi, for example, Bluetooth are really good for streaming Netflix or wearables, headsets and things like that. And even though they are low power to a certain extent and they provide wireless connectivity, they are not always good for many IoT solutions. So we made a little bit of an overview here. So you have the range and the power consumption and bandwidth. Those typically go hand in hand. And LoRa, LoRaWAN is a technology that drives really this part of the spectrum. So long range, low power, and also low bandwidth. And the magic number today is 10. 10 kilometers of range, that is a promise. 10 years of battery lifetime, it's also a promise. So what does that mean? A lot of new use cases that you can drive with devices that run on batteries or that run completely autonomous on small solar panels that charge themselves during the day and that provide power through the night. But also very long range. There's very little to say about range because it really depends on the environment, and I will tell a little bit about that later. But let's just talk about a few use cases to get started and to give you kind of an idea of what you can do with LoRa and LoRaWAN. So these are things that are actually being done on the Things Network. So some are really simple use cases that give some basic insight in the environment, and a good example of that is water level sensing, so around cities or areas where you have a lot of rivers and bridges, there is a community initiative on the Things Network that measures the water level by putting sensors like those in the top left under the bridges. And that gives some insight in what's going on. We also have, in agriculture, a lot of use cases for tracking cows, for example, and that has potentially a huge scale. There's some really nice devices, for example, and deployments all over the world, even in New Zealand on the Things Network. There's also the green sea turtles. That's a really cool use case. There's a nice presentation about that on the Things conference last year. You can find that on YouTube. And the idea is that sea turtles, they have a sensor attached to their shield. And the sensor measures how deep they swim and some of their behavior underwater. There's no coverage underwater, but the turtle has to go up to get some air. and then the sensor sends the data to a drone that's flying above the water with a temporary gateway. That's pretty cool. And we also have commercial use cases like Deutsche Bahn, a German railway, that is working on synchronizing their station clocks with LoRaWAN. So you can think of all these use cases, and also in agriculture again, a vineyard, measuring soil moisture. All of these use cases you can do without LoRa, but it makes it typically a lot easier, a lot cheaper, or a lot more convenient to use LoRa. So this kind of gives you an idea of what you can do, and I would take a few steps back and tell a little bit more about how it actually works. So LoRa physics crash course, just a primer of how the modulation works, and this is typically how data is transmitted through the air. So you have on the top left, you have a transmission with a certain transmission power, in this case 14 dBm. That's very little. That's, I think, about 25 milliwatts. There's some connector loss, antenna gain, and then the data goes through the air, and then you have path loss and fading. That's what happens when you send something through the air. And then here on the receiver side, there's some antenna gain, connector loss again, and then here you have the message. And what's really powerful about LoRa is that the receiver sensitivity is really low. Receiver sensitivity is minus 137 dBm. And that means that you can have a lot of path loss and fading, and still the receiver is able to demodulate the message. And that says something about the range characteristic. You can calculate the link budget by subtracting the TX power from the receiver sensitivity, and the link budget with LoRa is 151 dBm. And to put that a little bit into perspective, a Wi-Fi with 20 dBm transmission power has only 95 dBm of link budget. So here you see LoRa. And what's important here also to note is that, again, this is with only 14 dBm, a very high link budget. So here you see both of the characteristics, low power and long range, hence the name LoRa. And with this nice formula, you can calculate the theoretical maximum range. So Wi-Fi above on the well-known 2.4 gigahertz bands is only 550 meters. It's theoretical. You very often don't see this. If you leave your house or you leave your office, you very often already drop your Wi-Fi connection. And that is because there's always a lot of reasons, and I will get back to that in a bit. LoRa has a theoretical maximum of 850 kilometers. That's a lot. And so in our community, we have Thomas here. And Thomas lives somewhere in the middle of the Netherlands, next to the Weather Institute. And he likes to build weather balloons. And he just can lift them off from his backyard, which is next to the Weather Institute. So nobody really cares because the Weather Institute uses weather balloons all the time. And it's legal as long as you keep them to a certain size and a certain weight and things like that. So what he did is he attached a small sensor to it on a battery, and the weather balloon flew all the way to the Dutch-German border, and at about 26 kilometers, with, again, only 25 milliwatts of transmission power, it sent a message to one of the Things Network gateways here in Poland, which is 702 kilometers away. And that gives you kind of an idea of how powerful LoRa actually is. It's not something you do every day, but it gives you kind of an impression of the performance. And the reason why you can't cover entire Europe with only one gateway is because of these three reasons. First, there's a lot between the sensor and the gateway. So that's the attenuation, typically buildings, terrain, trees. There's in cities reflection and diffraction. So glass buildings, for example, they reflect signals, and that also causes interference. And finally, there's a Fresnel zone, and that basically makes it very hard also to predict the performance of LoRa in practical environments. So here you see an overview of what that means in a real-world scenario. So here you see on the left a city with the density, a suburb also, antenna placement, receiver placement, and you get an idea of the range. And you see here also in cities, especially also in dense cities, the performance is still really good. And we also see that in practice on the Things network. So that's about LoRa, about the physical layer. LoRaWAN is a software protocol on top of LoRa. It's designed for LoRa as the characteristics, with its characteristics. So maybe you know the OSI model. It's typically used to put internet protocols into an illustration. So you have here the different layers. On the physical layer, this is really LoRa. LoRaWAN affects all of these layers above. So there is no TCP/IP, for example, in devices. So there's not really the classical internet in the Internet of Things devices with LoRa. So there's no IP address, there's no confirmations, all the frame counting that you all know that's in TCP/IP doesn't exist, and that whole functionality is provided by LoRaWAN. So devices joining a network, encryption, confirmed transmissions of messages, routing, addressing, sessions, that is all defined in LoRaWAN. And that means that devices that are joining a LoRaWAN network, they need to have a stack. So they need to have a software on the end device that does all the LoRaWAN processing, and you also need that on the server. There are three classes of devices. So all devices are typically class A devices, and that means that they can send a message at any time, whenever they want. So it could be on an interrupt, it could be on an interval, it could be on a combination of those things. It could be some sensor message that it measured something, but it can also be a heartbeat saying, okay, I'm still here. That is what we call Class A, where the communication is initiated by the end device. In the meantime, these devices are typically asleep to conserve power. On the right-hand side, which is kind of the opposite, is Class C, which is network-initiated communication. And that means that the device is always listening, and the network can send data back. And this is typically not very good for the battery. So this is used either temporarily or in use cases where there is a power source, like street lighting. You have a power source, obviously, to turn the light on. Class B is a combination of these, where there is an interval and the network and the device have a moment, a few moments, for example, every minute or every 2 minutes, roughly, that the device wakes up and that the network has an opportunity to send a message to the device. When the device is not listening and the network tries to send a message, that message is basically lost. So we have to be aware of that, and also you see that back in the design of the applications, that you have to be careful whether you can actually receive a message. So a topology of a LoRaWAN network typically looks like this. You have the devices there on the left, the gateways, and again the communication between the devices and the gateways, that is LoRa. That's LoRa on the physical layer. A gateway looks like that. That is actually a Raspberry Pi 3 with an IMST concentrator board. You can build it yourself with a nice case around it. And because it's an Raspberry Pi, it also has a Wi-Fi backhaul. This is a gateway that we launched 3 weeks ago. It's the Things Indoor Gateway, which is a €69 gateway that we'll also be using today. So you can just plug this into a power outlet, and it joins your Wi-Fi network, and then it provides coverage. It's the cheapest gateway currently out there, and this gives you kind of an idea of what a gateway looks like. There are also industrial outdoor gateways that you can put on roofs, and they have IP67 casing, for example. So I can just stick this in, and it will hopefully join the Wi-Fi again. So that's on the gateway side. Then we have a network server, and a network server is handling the server side of the LoRaWAN implementation. Then there is an application server that's typically already application domain, but still it does a few LoRaWAN specific things. And then here is your user application, and that is where you have your Node, Python, PHP, whatever, Java, .NET, Go application, getting data and in various ways. Security-wise, there is security on 2 different levels, on the network level and on the application level. That's all defined by LoRaWAN. There are also 2 session keys, AES 128-bit symmetric encryption. And the session key is used between the device and the network for device identification and message integrity. And the application session key is used to join the network and to encrypt and decrypt application payload. So the network server typically doesn't have to know the application session key, so it can route all the data without actually being able to look into the data. Oh yeah, and what's also important to mention is that there is no connection between a device and a gateway. So we very often get the question, so how many devices can I connect to a gateway? The way it works is that a gateway is just listening on certain frequencies, and whenever a device nearby sends a message, the gateway receives that and routes that to the network server. That's all it does. A gateway is transparent, and you can add gateways to your deployment, and that increases the coverage, it increases the redundancy, and the capacity for downlink. But there is no connection. The gateway doesn't even know the end devices. So gateways are transparent in this case, and gateways is a little bit of an unfortunate name, but you should see it more as a gateway to the internet for the end device. So a gateway has an internet backhaul, which is typically Wi-Fi, Ethernet, or 4G. Then we have the different regions, and since LoRa is designed to be used in the ISM bands, the industrial, scientific, medical bands, that don't require a license from a spectrum regulator, everyone basically can set up a LoRa network. So this is sub-gigahertz frequencies. So here in Europe, in the green colored area that's authorized by ETSI, the frequency is between 863 and 870 megahertz. The downside of these bands, sub-gigahertz bands, are that they are not harmonized globally, and that means that there are differences across the world. So in the US, for example, the ISM bands for sub-gigahertz are slightly above 900 megahertz. In Australia as well, in Southeast Asia also, but they're a little bit different again. And then here, India and Russia follow mostly the European frequency bands. And this also means that certification and certification is different for devices that are made for the European market or for the American market. And this is unlike, for example, Wi-Fi and Bluetooth, which all work in 2.4 and 5 gigahertz, which is globally harmonized. So that's a little bit of a downside of LoRa. But nevertheless, most devices don't physically roam from one area to the other. And if they do, they would have to have some mechanism to detect where they are. And this is also actively being developed by the LoRa Alliance, that devices that are, for example, mounted on a ship, when a ship goes from Europe to South America, for example, that they can detect where they are. Then a little bit about the limitations. Like I said, it's long range, but it's also low bandwidth. And low bandwidth means that the messages that you can send back and forth are really small. And it's in Europe, the maximum size on the lowest data rate is 51 bytes that you can send. So that's one limitation. If you increase the data rate, because the device is closer to the gateway, if it has a good signal strength, then you can go up to about 222 bytes. Another limitation is the duty cycle. And in Europe, for example, where duty cycle applies, that means that you can send only 1% of the time or 0.1% of the time, depending on the channel that you're using at that point. And we typically define a frequency plan as an 8-channel frequency plan or 16-channel frequency plan, depending on the gateways that you use. So you can use channel hopping, so you can spread your channel utilization across different frequencies. But still, these frequencies have a duty cycle, and that means that you cannot send continuously data. So you cannot do phone calls over LoRa or watch Netflix, basically, because of duty cycle and maximum message size. Now, Jan is going to tell a little bit more about the ARMS IoT offering, and I will come back later for the Things Network offering.
Very good. Thank you, Johan. So this was what I was saying about the microphone dance. All right, there we go. So you might wonder, what does ARM have to do with any of this LoRaWAN thing? Why is ARM investing in this? ARM is a company that designs chip architectures. If you have a smartphone in your pocket, which I'm pretty sure everyone has, there's an ARM processor in that. That doesn't mean that ARM makes those. We do chip design, or processor design, architecture design, and other companies license that. So what are we doing with this IoT thing? When we're looking at IoT going from 0 to 1, kind of what we're doing today, it's really easy. It's kind of a solved problem. Anyone can take an Arduino or a small dev kit and get something up and running really quickly. Sending data from sensor to cloud, trivial. However, we see that it gets complicated really fast. So if you're doing one device, you don't really care about battery life that much. I mean, it's fine if you have to change batteries every month. You know, it's just a one-off that you're building. You don't care too much about security, so we see that, But if you're scaling your deployment, if you're going to tens of thousands or hundreds of thousands of devices, these things become really important. So we start adding complexity. So we need a TLS or some connection. We need low bandwidth usage. The device needs to have an identity. So we need to know that the device is what the device says it is, and we know that we need to trust that data. But that means we need to inject that identity at some point. So there's a provisioning step somewhere, maybe in a trusted facility, maybe you buy this from somewhere else, or maybe it's a technician that walks to the device and then manually injects that identity. But we need to have a way of doing that. So we need a provisioning service, and through that we need to have a key storage that is actually protected. And with that we need some factory tooling. So once we go into a factory and we tell our factory in China, say, hey, inject these identities for me, that actually have a way of doing that. After that, after a couple of years, and this becomes really important if you're doing a long-term deployment, you need to do a firmware update because something changes. We see that actually in Europe with LoRaWAN, because right now, as Johan said, we're using 863 to 867 megahertz, but the European Union has said that they also want to start using 915 megahertz band. In addition, we might get some additional spectrum in the 870 megahertz band. If you have an IoT deployment that you did 2 years ago, or LoRaWAN deployment 2 years ago, and all of a sudden this additional spectrum is available, but you can't use it, and maybe they put extra limitations on the current 868 megahertz band, you're kind of screwed. And if you have a 10-year deployment, that is something you really need to take into account. And then maybe 5 years down the line, all of a sudden your whole company gets bought, and you need to do transfer of ownership of these devices. Maybe it's your building that you made smart. If you have a new tenant, you need to do transfer of ownership. So and then maybe you even have a gateway in place. So this is even when it's connected to the internet is hard. But if you put a gateway or put devices in the mix that don't even talk IP, like LoRaWAN devices, makes a really, really complicated thing. So something that's really easy if you're going from 0 to 1, connecting a device to the internet, is really trivial. It gets really complicated if you start doing a lot of devices. So within ARM, we saw that right now everyone does it themselves, which is possible. I mean, it costs a lot of work. But what we also see is that this is stuff that doesn't directly add value to your product. Your customer, or the person buying your product, only sees data flowing from a sensor to the internet. And all this complexity behind this image, they don't really see that. That only shows a couple years in. And this is how we ended up with this whole internet of insecure things and an internet of unupdatable things. So ARM has always been about doing stuff in a partnership, doing stuff together. We realized quickly that if every company has its own architecture, in the end that's bad for innovation. Not saying that everyone should unify on a single architecture, but having 100 different ones, that is not great. So in ARM we said, well, why can't we do the same thing for software and IoT? So we started building two products. One is called MBED OS, which is an operating system for microcontrollers. So an operating system for really small devices, which is open source, free to use. We're going to be using it later. That solves all the device type of stuff. It solves identity, it solves key storage, solves factory tooling. And then on the cloud side, we have ARM Pelion, which is a software as a service product that serves everything on the cloud side. So the idea there is that if we build this together, so we build MBED OS, for example, with ST, which we'll give a presentation after, everyone can just focus on where can I add extra value in my IoT deployment, and not about solving these basic problems that everyone needs to solve. So that went too far. So one of our tagline is that we want to do secure connectivity and management from chip to cloud during the full lifetime of the device. So one of these core parts, the part that we're actually going to be using today, is MBED OS. And a couple of years ago, we were already having MBED OS. We're not doing anything with LoRaWAN. However, we're seeing that the same issues that we see for other devices, adding complexity, adding new security features, firmware updates, are also popping up in the LoRa ecosystem right now. So LoRaWAN is really evolving. In the latest version of LoRaWAN, LoRaWAN 1.1, we have new security principles that need to go into your device. We have firmware updates that are actually standardized now. Johan and I did a lot of work on that. And then there's ongoing work around device management. How do I know where my devices are and how I can control them? And all of these things add complexity. The clicker is not working that great. So complexity, really nice green arrow. So in ARM, we saw that and we figured, okay, we have this increased complexity. We have a lot of stuff that happens under the hood that you kind of should implement if you want to have an IoT deployment that's going to last for years. And very little people do it. So kind of the parts required in a LoRaWAN IoT device is asymmetric crypto to do verification of new firmware that's incoming. We need a resilient file system. What I see happen a lot is that people take a bit of NOR flash. They just write to the same sector. And 2 years in, the sector breaks. And now what? So we have stuff like we add extra resilience with little FS. We need radio drivers. We need power management. Because squeezing an extra year of battery life out of your device actually saves money. Very often, it costs more money to send a technician to the device to replace the battery than the actual device costs. So squeezing as much out of that is really important. And we need an advanced LoRaWAN stack to take advantage of all the new developments in LoRaWAN. So in ARM, together with partners, we built MBED. So MBED is a platform operating system. I don't know who came up with that term, but there we go. It's an operating system with a bunch of middleware modules that are well tested, that we developed together with a wider ecosystem, together with a really big developer community, and with our partners, where we're saying, okay, we're going to handle all the boring stuff that you need to take care of when you're building an IoT device. So it comes with a real-time operating system, portable drivers, security integrated, and connectivity stacks. It's easy to port. We currently have 150 development ports available that all work out of the box with MBED. I did a port together with Johan for their new product. The other day, it was actually not that hard. And we have IoT connectivity. So besides LoRa, we also have Bluetooth Low Energy. So these are actual stacks. It's not like we're reusing something from someone else. We include these stacks in the product. So full certified LoRaWAN stack, Bluetooth Low Energy 5.1 stack just came out end of January, but also a certified 6LoWPAN stack, certified Thread stack, IPv4, IPv6 stacks, Wi-Fi connectivity, cellular, etc. So core to us is that we can't build this in a vacuum, right? ARM is not the company building actual products on top of this. We can help facilitate it We need other people to take this and actually start building things on it. So that's a really important reason why we do this completely in the open. So the project is hosted on GitHub. It's licensed under the Apache 2 license. You can just take it, implement it in your product. No attribution required. Last year, we had over 3,000 commits to our core repository from over 300 unique contributors. I think it's awesome. Like every day, someone just opens pull request, adding new functionality or fixing bugs, etc. And then if we're looking at like the number of commits spread out between wider community, our partners, and ARM, we maybe only do 40% of the work. A lot of the work is actually done by companies like ST. They have a number of engineers to make sure that every time they bring out a new Nucleo board, the same, or a new, whatever, a new SOC or a new system in a package, to make sure that it actually runs on MBED. We don't do that. It's our partners that do that. And that's the only way to do it. It's not a toy. Today you're going to be using the online compiler, which is really easy to get started, but you might have this idea of, okay, well, this is cool for prototyping. Now what? But it's actually an operating system used by real companies to build real products. This is just a small subsection. If you go to our website and you search for Build with Embeds, you'll find a whole list, including what they're using and why they're using it. One of the cool things here is the one from Baidu. Baidu has a kind of Alexa-type speaker, so you can talk to it in Chinese. And say, ni hao, and then we'll talk back. I guess, I don't speak Chinese. Yesterday someone said we should make more jokes during presentation. So, but they're actually building that on top of MBED, and I think that is really awesome. So our relationship with LoRaWAN is quite old. Back in 2015, when Semtech came out with shields, like LoRa radio shields, MBED was one of the first platforms they supported. And that is, in our community, you see that. So LoRa is really big, and it's growing in our community. You might not be able to see it from the back or on the video feed, but we asked in our yearly developer survey that 2,500 people responded to last year, if you're going to use a connectivity method in your IoT platform in the next year, which connectivity method do you think you're going to use? In 2017, 13% of people said they were going to use LoRa. In 2018, it's 22%. This is insane. Like 1 in 4 of the developers on our platform actually consider using LoRa, up from 13%. It's cool. So we figured we have companies doing stuff with LoRa on MBED, but it's not in a supportive way. It's just a company like Multitech or a company like Semtech saying, well, we support it and here's a library, but we figured we wanted to have it in the core operating system. So we asked Etteplan about a year and a half ago, like, can you guys help us build a rock-solid LoRaWAN stack that actually runs on all those 150 development boards? So that is now landed. So right now we have a full certified LoRaWAN stack in MBED. It's supporting the latest versions of LoRaWAN. So right now there's 3 versions out. LoRaWAN 1.0.2, which is kind of the stable version. Also the only one that has a certification program. LoRaWAN 1.0.3 and 1.1.1, all supported by MBED. We've really focused on the features that we think are important if you're going to scale this out to tens or hundreds of thousands of devices. So it has firmware updates built in over multicast. So as Johan said, data rates are really low for LoRaWAN. But what we can do is actually broadcast firmware to many devices at the same time. So as long as they're near one base station. Highly configurable, supports all the channel plans that the LoRa line supports. And really important is that it's certified. So we certified our stack. Etteplan did it for us. So whenever you take this, you can be sure that it actually adheres to the specifications in the LoRa lines. It's small, so the whole stack plus the operating system plus the driver model in the smallest configuration fits in 6 kilobytes of RAM. And this can be completely statically allocated if you want. If we're going to be using stuff like firmware updates, this shoots up quite a bit. So for firmware updates, we need about 18K of RAM because we need to have asymmetric crypto, because we can't trust that whatever comes from the network is actually what you want to flash in your device. Firmware update is also a big attack factor. To deal with that, so the board that you're going to use today has 20K SRAM. So if you're going to use a firmware update client that uses 18K, you have only 2K for your application. That's very little. So one way of making this smaller is by using an external crypto engine. So 2 weeks ago, together with the Things Network and Microchip, we announced integration of the Microchip ATEX 608A secure element. So one, it's a crypto accelerator. So it can do all the crypto operations that you need to do in LoRaWAN a lot faster and without requiring software crypto on your device, so saving some RAM and saving some flash. But also this comes with an identity in it. So this board, this little chip, it's really this size, by this size, has a device EUI, and it has root keys in it. So once you pop this on, your whole provisioning solution, your provisioning story is kind of solved. Just pop the secure element on it, bam, device's identity, keys can never leave the secure element, and our stack can automatically use that. So testing is really important for us. If you're going to deploy this, you need to be sure that this stuff is going to work and it's going to keep working. So in MBED OS, we have over 1,100 functional tests that we run on a farm of over 800 devices. So you see one of these clusters here in Austin, Texas. There's just a big cabinet full of development boards. So every time someone opens a pull request, we just run our complete test suite to make sure that we don't break anything. Then in addition, whenever we have a major release, we actually do certification testing with a test house like Etteplan to make sure that we actually adhere to the specs. We also bought 2 of these bad boys. So these are big, rugged test boxes, RF test boxes. And through this, we can run our own certification tests. So hopefully, in the near future, we can run nightly certification tests in all the regions. Last about MBED is that the secret behind LoRa's battery life, one is just sleeping. If you're constantly sending, you will run out of battery life really quickly, and you'll never reach this 10 years of battery life. So we need to sleep as much as possible. So to do that, we have automatic sleep management in MBED OS. And that's automatically integrated also with the LoRaWAN stack. So whenever you don't do anything, whenever you just wait on a thread, we automatically put the device into sleep or in deep sleep. So I had a STM32L4 device, so low power device from ST. And I had it run for 24 seconds. And in that, I did a join with the network and 4 uplinks. So it took 24.1 seconds. Out of that, I only had to be awake for 0.3 seconds. So that's just wake up, drive the radio, open my receive slot after a second, see if there's something incoming. No, okay, go back to sleep. And I managed to be in deep sleep for 23.6 seconds. So that's something you get out of the box. It doesn't mean that there's still stuff where you need to shut down your own peripherals. So it's not a magic bullet, but it's going to help a lot with building battery-powered devices. All right, so let's say that you're now as happy as an Asian girl in a ball pit. And you want to start developing, actually what we're going to do today. One, pick a dev board. So this is a small subsection of the dev boards that we support. After doing print screens 6 times, I kind of was bored and I went to do something else. So we have twice as much as these. From a lot of vendors. So we have a lot of boards from ST, we have boards from NXP, we have boards from Nordic Semiconductors, Multitech, wide variety. You need to pair it with a LoRa radio. So what we're using today is a target with a built-in radio. So you get a board in a little bit, and it has this board. There's just one chip on it, shielded, and that is both the microcontroller and the LoRa radio. In that case, you're done. If you're using a microcontroller that doesn't have a LoRa radio, just pick one of these shields and plug it in. It's so easy. There's 3 ways of doing the development here. One is by using our online compiler, which we're using in the workshop. Really easy, you just go to a web page, type some stuff in, and click compile. Nothing to install. The second thing is MBED CLI, which are command line interface tools. That's what I use. Or you can use an offline IDE, integrate with that. So for example, with IR, with Kyle, or with Eclipse. I'm using Visual Studio Code for that. So wide variety. So the online compiler, new program, type whatever you find here, and there you go, you have a complete development environment. With MBED CLI, we can start like that. And then I want to hand it over back to Johan, who's going to tell a bit about their new product. Can we check if the sound is still working? This is very professional. professional production.
Yeah. Even though end devices, programming, everything, ARM makes that really easy and accessible for everyone, free also, open source. We decided to make it even a little bit more easy and remove the whole programming part. So we are launching a new product, the generic node, which we also announced 3 weeks ago. And the generic node is a device that contains around 9 sensors and can run, or we built devices, or we built applications for this device using MBED OS. But with these 9 sensors, excuse me, we defined around 20 to 30 different use cases. And we are implementing those use cases as an MBED OS application. They are open source. We put that in a repository online. And without having to do any programming, you can load these applications on the end device. In fact, this end device supports firmware updates over the air. So you can also pick a standard application that we built or that somebody else in the community built, and you can send that to the generic node without having to do any programming. But if you want to do programming, then you can do that because we also have a programmer available. So you can write your own MBED OS applications. You can take the reference applications, make your adjustments, and put them on the generic node. We designed this really as a next generation LoRaWAN device. And that means that it supports end-to-end encryption. So it has that ATEC 608A crypto chip that's provisioned on the joint server. So you don't have to think about key provisioning, and nobody is able to read the root keys because it's physically protected. Second, like I said, it supports firmware updates over the air. So if you have a device deployed in the field, you can still update it during the lifetime of the device. It's ultra low power. It's a 1.8 volts design with a replaceable AA battery. So that means that everyone can replace the battery, and AA batteries you can buy them in every supermarket, basically. Open development tools, so that's really driven by MBED OS, and it's operator agnostic. So you don't have to use the Things network. You can use it on any LoRaWAN network, private network, commercial, public network. So what really is the Things network? The Things network is it's a variety of things. We started out with a mission 3.5 years ago. And this was sort of a social experiment. This is my co-founder, business partner, Wienke, at the Internet of Things meetup in Amsterdam, pitching a mission to build an open, crowdsourced and decentralized Internet of Things data network. So what does this really mean? We earlier, Wienke, at the same IoT meetup in Amsterdam, saw KPN presenting LoRa. They were talking about technology and announcing their nationwide commercial LoRa network. And everyone can set up a LoRa network. So we started thinking to do that as well, but then in a community way. So decentralized means that the Things network is not a central operator. It's not that we route all the data. Open means that it's open source, but also everyone can add coverage to the network by installing gateways. So you can buy a gateway, put it somewhere, and you become part of the network. And crowdsourced means that we don't own the infrastructure. So the people own the infrastructure. That is the Things network. So this started off really small, hacking together and building the first community in Amsterdam, covering Amsterdam in a few weeks' time. And now, 3.5 years later, we are in more than 900 cities. So those are communities. So there's also community here, all over the world. So there's a map that you already saw in the next slide. In about 137 already countries. Different server locations around the world, most of them used for packet routing, with about 6,500 gateways. It's also the biggest global LoRaWAN network, and 65,000 users. That's basically the LoRaWAN developer community, which uses the Things network. So it's a free service, it's open source, and you will also going to use it today. So you will get acquainted with that if you're not already. So globally, this is the map where our communities are located. And you'll see a lot of density in Europe. It's kind of a good reflection, I would say, of LoRa at this point. So LoRa originated from Europe. It's well known in Europe also because there are European operators that committed quite early on deploying a nationwide LoRa network. And we also see a lot of growth from emerging markets, South America, for example, Southeast Asia as well. There are some really strong growing and big communities here in Australia, even though you don't see any communities here. This is mostly desert. But we're also hoping that there is also more communities growing there. And in the US, also strong growth in TTN communities. So that's pretty cool. So that's the community side of things. That's also the network side. It's a people's network. It's also a gateway network and a devices network. But the things network is also a technology. So we built a stack, and the stack is the server side for routing all the traffic and doing all the LoRaWAN magic. So 3 weeks ago at the Things conference in Amsterdam, we released the open source distribution of version 3 of our stack. We've been working on that for about 1.5 years. And this is the architecture. It's open source. It's also Apache 2 license, so the same open source license, permissive license as MBED OS. And we have a couple of components here. So here you have the gateways. Again, the devices that give coverage to the devices. They are connected to a gateway server. A network server is primarily doing the LoRaWAN, MAC layer stuff. So everything that I presented earlier with respect to sessions, join procedure, message confirmations, things like that. Application server already lives in the application domain, so it does decryption of payload. So it has application session key, but also here makes the data available in various ways. So you as a developer work with your data through MQTT, for example, HTTP webhooks, or using one of the integrations that we have with public cloud platforms. The Things Network, community network, is operated by a few parties. And the Things Network Foundation, which is a non-profit foundation, operates 4 clusters in Europe, US, Brazil, and Singapore. And then with the help of a Swiss association and Mesh in Australia, as well as Digital Catapult, I should put that on this slide, Digital Catapult in the UK, and also YISC in the UK now, we operate a global network. And is Marius here? Marius, yeah, he is also setting up an association to operate a public cluster in Poland. And that would drive the Eastern European part of the network for the routing. And that also makes it decentralized. Apart from that, we also have ongoing conversations with parties in other countries to extend the routing. So, for example, in South America, Japan, China, and that's really cool. So we are already deploying that, or we are pretty far with doing that. Yeah. So that's the Things Network, community network, the open source distribution, the routing network. Then we have the Things Industries, and that's our commercial entity where we employ the team. Like I said, we have around 18 people there. We also organize conferences. And what we do here is basically, because the Things Network is a free network, what we do here is to make the whole initiative sustainable. And the way by doing that is that we build the technology, and we also offer that to companies that want to set up a private network. So if you need an SLA, if you need custom integrations, if you need your own network with your own infrastructure, then we can provide that through the Things Industries. And by doing that, by building that, we also contribute to the community by making most of the stack open source. We also have online, that's what our product really is. It's primarily two different things. We have our websites with documentation where you can learn about devices, gateways, network, applications, but also about LoRaWAN in general. We have the community site where you can join a community, you can create a community if a community in your city doesn't exist yet. We have the forums, which is basically the LoRaWAN forum. We have a public Slack where you can chat with anyone around the world. We have labs where you can read tutorials, but also create tutorials on how to build certain use cases or work with certain devices. And then we also have the technical side, which is the console, and that's our environment to manage applications and gateways, and you will also be doing that today. What is really nice about LoRa is that because everyone can set up a network, you don't have to use a private network, or a public network. You can also do a private network. And so what we offer through the Things Industries is a hosted solution, a SaaS solution, a private cloud where you can have your own network on your own server, or that's on premises, or private cloud where you run the entire stack in your own Amazon, Azure, or Google Cloud account. Like Jan said, the secure element, I think that's a really important key driver for securing LoRaWAN devices. So we are very happy to launch that together with Microchip and also with great support from ARM. And we have some additional features. Pairing is also one it's good to mention, which is exchanging traffic between networks. So even though we have those multiple clusters around the world, it's actually one network. So all the traffic goes to other clusters. If a device shows up somewhere, we route it to the right place. So getting started, you don't have to do this now, but you will do this actually as part of the workshop. But everyone that's watching at home, please do this right now. You can create an account. You can manage applications, gateways, devices in the console. Learn about LoRaWAN, watch the webinar series, and read the documentation to get yourself acquainted with LoRa and LoRaWAN. And then Jan is going to do his famous Steve Jobs moment.
Thanks, Johan. All right, last part. I realize that we've been talking for 52 minutes by now. And I see you guys eager to actually start doing something. So one more thing. So within ARM, in my team, we're not just looking at what is here today for IT development, also a little bit forward-looking. So we run a thing called MBED Labs, and if you're currently thinking, okay, what in the next 2 years, in the next 3 years, what is the Internet of Things going to look like? We have a number of projects in there that I wanted to highlight that I think are going to be really interesting. So the first one is MBED.js. So I'm originally a web developer. I came down the stack. First started working on Gecko, the render engine behind Mozilla Firefox, and after that I figured that was not low level enough, and now I needed to do actual embedded work. But now I'm stuck doing assembly in C and C++ all the time. Can't we do better? So we're working on a JavaScript engine called JerryScript, and JerryScript provides full ECMAScript 5.1, so full JavaScript support in 64 kilobytes of RAM. So that's something actually run on your development board, make it easier either for people to write plugins or write smaller applications, or just write maybe their full JavaScript application straight for an IoT device. So that's something we're doing. If you want to learn more about that, go to mbed.com/js. Runs on a wide variety of boards. One of the other projects, and this might not be as relevant for you people right now, it might be relevant afterwards, is that we have a simulator. So with that, you can take an MBED program, compile it on your computer or in the browser. So we have two versions, a hosted version and a local version, and then run your MBED application there without a board. So one of the things we have is a integration with our LoRaWAN stack. So you can take our LoRaWAN stack and MBED OS, compile it, and then actually run a LoRa node and a gateway all in one on your computer. So you can test this out by just going to labs.mbed.com, click on the simulator, click on LoRaWAN, and just putting some Things Network keys in it, and then you'll actually see it join the network, and you can actually interact with it like it's a real device. So here I have the community edition of the Things Network. So this is open. Johan did not know anything about this. And on the left I have the simulator. So when I start it, it compiles, takes about 5 seconds. And this takes our actual LoRaWAN stack, so it's our certified stack. And then we see the device joining the network, and then actually start relaying data back and forth. So device joined, now it sends stuff. So this is a really cool way. Like, Johan and I worked on firmware updates. 90% of the firmware update code was actually written in the simulator before we even tested it on a real device. Johan and I were sitting next to a pool in Bali, hacking along. In the morning we went diving, in the afternoon we went hacking on firmware updates. And we didn't even bring a gateway. So it's really cool. So it makes it a lot easier to develop. The last project is microtensor. And microtensor is a way of taking a neural network trained in TensorFlow, scaling it down, quantizing it, and putting it on a microcontroller. So we have the MNIST dataset. So that's a dataset of 60,000 handwritten digits, already created in the 90s. We used a neural network. We trained a neural network based on those images, and now we run the inferencing on a STM32L4 device. So you can draw on the screen, click a button, and then we'll do the inferencing through the neural network and actually tell you what is happening here. So in this case, the 3. Someone actually yesterday asked me, like, don't you think it's weird to put a beer in your video? But that was my colleague who actually did this. Not my fault. And here we can also do an 8, and then we'll get us an 8. And I think this is really cool part of the future of IoT. Like, currently we treat IoT devices as a place where we gather data and then we just send the raw data off somewhere to be processed. But if we can start running our neural networks directly on the device, I think that's fantastic. I think we're just getting started with what's possible. But you can have real autonomous devices making decisions and just sending the conclusion over LoRa. Like a people counter that has a camera feed and needs to count the number of people. You can't send the raw video feed over LoRa. But if you have a neural network that you can run on the camera and just say, hey, I saw 8 people, and send that over Things Network, that is easy going forward. Last, we said it a couple of times already, firmware updates are really crucial if you want to do a long-term deployment. Johan and I, together with Nicolas Sornin, did a lot of work on getting this actually standardized. That is all ready now. So if you're more interested in that, just Google firmware updates LoRaWAN. You'll see this great video of 2 handsome guys pop up at the top of your Google feed to learn more about that. So to recap, and then I'm going to hand it over to ST. LoRaWAN is really awesome. 4 years ago, I started working with this technology. I just randomly ran into it. I thought it was fantastic. After that, I started building a network in Oslo for my previous employer. The moment that we put up a gateway, and then I went downtown in Oslo, and it's about 8 kilometers distance, and I was downtown in Oslo with my dev board, and I still saw my signals being picked up by the base station. I was like, holy shit, that is fantastic. That is so cool. However, remember the limitations, right? There's duty cycles. The data rates are kind of slow. But regardless, it's fantastic technology. And MBED OS, the Things Network, and Etteplan are really here to help. So if we have a customer that wants to do a LoRaWAN deployment or even just an MBED OS deployment, and they have to scale, we send them the Etteplan. I just did it 2 days ago to Jaco. Like, we trust these guys. So if you need help with building a product, go find Jaco or find any of the other people here in Wroclaw. So, and then last thing, remember, let's build this thing together, right? For the first time, and I used to work for a telco. Right? I worked for a telco building a LoRaWAN network. For the first time, we as a community have the power to say, shit, we're just going to do it ourselves. And the fact that someone here in Poland is actually going to build a cluster in this decentralized network, I think that's fantastic. That's really cool. We can just put up a network and build this with a community. So through that, this is less dramatic if I have to click my clicker 3 times. So with that, I want to thank you all for being here. And I think it's fantastic, and we're going to have a great workshop after this. Thank you. And